Hello students, welcome to LJ Institute of Engineering and Technology. Here myself Mr. Jaiswal Kishan from Civil Engineering Department, and we are learning all about structural analysis. Now in today's session we will be considering some examples. Let's see. Now today we will be considering a 3-span beam examples. Before that, look, this was the 2-span beam which we did in previous session. This is similar to that, in which we make any one of the as a redundant, then we found out reaction, and then with the help of this reaction we draw bending moment diagram. With the bending moment diagram we find out VA dash and VC dash, and then we found delta at respective points. So after finding out delta, we form del VB, and with the help of formula of VB, we found reactions for VB, and then we make equation for another terms like VC and VA, and then we draw a diagram. So this was the process of 2-span beam. The similar kind of process we will be following in 3-span beam. So let's see. For a 3-span continuous beam, draw ILD for VA, VB, VC and VD. Calculate ordinates of ILD as shown. Now here, not given for 1 meter, 2 meter, but it is written that as shown. So here it has been shown that this point 0, 1, 2, 3, 4, 5, 6, 7, and with respect to distance pause for 1.5, then 2 and then again 1.5. So we have to draw as per shown. Now here there will be two unknown. So we will be taking B point and C point as my primary unknown. Now consider VB and VC as redundant. Place unit load at B and find out deflection at various section. Similarly, we will be placing unit load at C and finding out deflection at various section. So one by one we will be placing unit load. Earlier it was only one unknown, so we placed one unit load at that point only. But here there are two unknown, so we will be placing one by one unit load. So here, first of all, I have ignored C point and placed unit load at B point. Then we found out reaction as a similar process to 2-span beam. So VD multiplied by 11.5, the entire length, equals to 1 into 4.5. Then we will be finding out VD and VA. After finding out VA and VD, we will be drawing this bending moment diagram. So it is nothing but VA multiplied with this distance, and from this side VD multiplied with this entire distance. So we will be reaching somewhere over 2.7. And then we will be finding out VA dash and VD dash. So for that we will be using this triangle as a load. Then after finding out VD dash and VA dash, we will be finding out deflection at each and every point. So point 1, point 2, point 3 with respective distance. So values of delta XB. So at x equals to 1.5, over here VA dash multiplied by 1.5 minus this triangle, its area into CG. So similarly we will be finding out till here with the help of VA dash, and from here to here with the help of VD dash. So here till look here, I have first used 8.5 VA dash and then later we used VD dash. So we have found out the value of delta at respective location of x. This is much similar to the previous sum. But look here, I have made two different colors of this highlighted portion of this two different points. This will be coming ahead, just mark this. Now we will be doing unit load at C and finding out VA and VD. With the help of VA and VD, we will be drawing this bending moment diagram. And then with the help of this bending moment diagram, we will be again finding out VA dash and VD dash. So after finding out VA dash and VC dash, we will be finding out delta XC. C stands for point load at C. So the same distance as given. So we will be finding out delta XC at distance 1.5. So which is nothing but VA dash multiplied by 1.5. So VA dash is nothing but 5.36 multiplied by 1.5 minus this triangle area into CG. So 1 half base into height multiplied by 1/3 of 1.5. So till peak load over here, we will be using VA, and for this point we will be using VD dash. So look, for the first half I have used 5.36 and then I have used 7.39. Now after finding out this again deflection at each and every point, now we are having two deflections. Deflection at B, delta XB, and deflection at C, which is delta XC. So now to find VB and VC, we have 6 pairs of simultaneous equation. So the equation will be VB into del VB plus VC into del VC equals to delta XB. Similarly, VB into del CB plus VC into del CC equals to delta XC. So look, VB and VC are my unknown. This is my distance X. I have to find value of VB and VC. So at 0 point and at 11.5, its value will be 0. Because delta 0 equals to 0 and delta 11.5 equals to 0. But for remaining one, what to place? VB will be my unknown, VC will be my unknown. Now how to find this all value? Look, delta XB and delta XC is nothing but respective value for their distance. Look, for 1.5, delta XB is nothing but 12.33. Look, I will show you. 12.3. Then it was 22.5. Then 28.7. 12.3, 22.5, 22.6, 28.7. And these are for respective del XC, which is over here 7.89, 14.9, 20.2, 7.89, 14.9, 20.2. So VB is my unknown, VC is my unknown. These are respective delta's value. Now to find out delta BB is nothing but deflection at P due to unit load at P. So here it is my unit load, and at this point, which is distance 3 plus 1.5 is 4.5. So this is my delta BB, so which is 28.76. So 28.76 will become my delta BB. Similarly for delta CC, unit load at C, so at this point, which is nothing but distance, this 2 plus 2 4 plus 3 7, 8.5. So for 8.5 it is nothing but 18.8. So our delta CC value remains fixed, 18.8. So 28.8 and 18.8 we have found out. Now what is delta BC and delta CB? Delta BC is nothing but load at B, deflection as C. So here load at B, the value will be 20.2. Similarly, we used 20.2 at 4.5. So that's why 20.2 and 20.2 delta deflection P due to load at C, delta CB is nothing but deflection at C due to load at B. So both value will be 20.2. So we have found out the entire value for this, and these are respective changing values to delta XB and delta XC. And after forming this two equation, so we'll be solving this two equation, then we can find out the value for VB, and if I find out value of VB, we can place in any one of the equation to find out the value of VC. So like this way we can find out the respective value of reaction at B and reaction at C. After getting this VB and VC, we will be using the figure and form an equation for VA and VD reaction. So taking moment at t equals to 0, so VA multiplied by 11.5 plus VB multiplied by 7 plus VC multiplied by 3 equals to 1 into this distance, which is nothing but 11.5 minus x. So making VA as a subject, I got one equation. Similarly, I will be making equation for VD. And then just place the value of VB, VC and x. X is nothing but this respective distance. Now for 1.5, the VB value is 0.54 and VC value is minus 0.163. So placing that, I will be getting VA in this equation, and if I place x, VB and VC value of this two, then I will be getting my VD. Similarly, we can find out value of VA and VD. So just the difference was this. This was the difference in the table. Then after forming the values of all the reaction, at last we have to draw a diagram with the respective ordinates. This is for VB, this is for VC, and this is for V, and this is for VD. And all the diagram will be in the format of curve, because ILT for indeterminate structure, the diagram will be in curvilinear. So let's have a quick revision. What we did, we placed unit load at B and then found out its deflection. We placed unit load at C, then found out its deflection, and this is a new equation in which we place respective values and solve by elimination method. So we got value for VB and VC. Then we use figure for forming an equation for VA and VD and placing the value of VB, VC and X to find out value of VA and VD, and draw bending moment.